Hi, my name is Tiagi, and in this video I'll be explaining how nuclear reactors work. So a nuclear reactor is a modern type of energy power plant that helps to create clean energy. And while nuclear reactors aren't renewable because they require on radioactive materials, which aren't renewable because there's a limited amount of them, they are really efficient at what they do. So just for context, 1 kilogram of radioactive fuel can power the average American house for an average of 34 years, which is kind of crazy to think about. 1 kilogram power for 34 years, an average American house. And in recent years, this technology has been on the decline. So from 1996, which was at the peak of nuclear energy usage, we had 18% of American households were powered by nuclear energy. But now today, we only have about 9% in 2025. And so the main reason why it's been declining is because, costs and obviously public support, right? So a lot of people are afraid about, you know, safety of the technology, whether it could leak out in the environment, stuff like that. And that's kind of a big reason why these aren't being built nowadays. But I just wanted to explain to you guys how these work, just to show, what the danger is with them and just show how they work. So to start, nuclear reactors are really similar to how conventional thermal power plants operate. So what I mean by this is they also use heat to produce energy. They use thermal energy to make energy. And so while traditional ones use coal or natural gas or biomass, which are dirty, types of energy because they release carbon dioxide or other bad materials in the environment, nuclear energy uses radioactive materials, which only release where they release radioactive waste, but we can store that waste safely, and they reduce steam, which is not a dangerous thing to release in the environment. Okay, so how do they work? So first step in a nuclear reactor is we have to start at the reactor. So this is the reactor, and in the reactor we have these rods, these fuel rods, right? And these fuel rods, they have these little uranium pellets in them. So a little uranium pellet. And just for context, these uranium pellets, just one of them, can power a house for around 1 year. So these tiny uranium pellets can power a huge amount of stuff. So these pellets are packed into these rods, which are called fuel rods. And then these fuel rods are then packed into these, uh, fuel things are packed together like so. They're placed in the reactor. So you can imagine we have these rods full of uranium pellets. And these uranium pellets are enriched. And by enriching them, what we do is we increase the concentration of uranium in them. And so how does this actually make energy? How does the uranium create energy? Well, the process of fission is how nuclear reactors work. So with fission, we have one neutron, and we have a uranium atom. It's not really a great one, but that's the uranium atom. And what happens is we bombard this uranium atom with a neutron, and this uranium atom, which is enriched, is going to split. It's going to split into some neutrons with energy, a lot of energy, kinetic energy, and it's also going to split into two more radioactive byproducts. Okay, and so when we do this, we also release a lot of energy, and it's this energy here that we release when we break it into these components that help to power the power plant. And so with this process, with one neutron colliding to one uranium atom, what can happen is these neutrons can then collide into more uranium atoms, and more and more and more. And so this process continues, indefinitely through a chain reaction. And this is how nuclear bombs work, right? They just keep going and going, and they produce a lot of energy and a lot of byproducts in a short amount of time. The issue is we don't want a nuclear bomb, right? We don't want to create a bomb for our power plant. And so we have to control this reaction, and that's the main focus and the main way, the main issue with nuclear power plants. How can we control this? And so the primary way we control this is through control rods. And so basically, control rods are these rods that are sticked into the reservoir, and they're filled with these materials, right, that are collect these extra neutrons. So instead of like creating this reaction, right, these rods absorb some of these neutrons. And so these rods are usually made of materials like boron or cadmium. And these are good materials to use because they can readily accept neutrons. And so by taking these rods, you can control the rate of the reaction and stop, a huge chain reaction creating a lot of energy. And just for context, one of these rods can stop a average reactor in about 1 second, which is kind of crazy if you think about it, because there's probably like a millions of these neutrons in this thing, and so it can stop all that in just 1 second. And also inside this reservoir, we also have this thing called boric acid. And so boric acid, or some other kind of moderator, what it does is it captures the excess neutrons. So instead of creating like a bunch of neutrons, it captures those excess neutrons, and it's able to prevent this huge chain reaction from happening. And the idea is with nuclear reactions, controlled ones, you want just one neutron to go to one uranium. So these extra 3 neutrons, they should only go to one. They shouldn't be, causing multiple uranium atoms to fission. They should cause only one. And so you can control this again with the boric acid and with the control rods, which you'd use to control the reaction. Okay, so with this reaction, the water inside the reservoir is about heated to about 320 degrees Celsius. Let me just erase everything. Okay, and this water is then pumped with these pipes into another reservoir. So it's pumped like so here. And here is a pressure gauge. And this pressure gauge is just here to make sure that the water doesn't, boil or become steam. We want it to remain just hot water. And so this pressure gauge does that by changing the pressure of the pipes in the system. And so this water is piped to this reservoir, and it goes in this like path through the reservoir to make sure the heat gets into this reservoir. And so this reservoir here is filled with water, just regular water. Okay? And so when the pipe full of hot water goes to this reservoir, it creates steam because you're heating up the water inside this other reservoir. And so this steam accumulates up here, and it's sent through these pipes. So here we have steam being sent through the pipes into the turbine. And so the turbine is literally just like a fan, right? And so you can imagine if we put air through it, it's going to spin the turbine. And so that's all it does. We put steam, hot steam, through the turbine, and it spins the turbine. And so this turbine, there's multiple blades that are connected to an axle. And so this axle is then connected to a generator. And a generator, that could be a whole other video how those work. But basically how it works is it spins. And by spinning this generator, you get an electromagnetic field. And this electromagnetic field creates energy. And so from this energy, we then use a transformer to increase the voltage of the produced energy. And we need to do that to make sure that it's deliverable to houses or whoever needs the energy. And then we send it to the power plants, to the people who need it. But what do we do with this hot steam? So once we have this hot steam, it goes to this cooling area. And this cooling area has this another pipe system. And this pipe system has cool water in it, or a coolant, cool water, coolant, whatever. Okay, and this coolant gets its stuff from this. So those big tanks you see, those are called cooling tanks, right? And these cooling tanks are filled with water, cold water. And the cold water is usually gotten from some lake or some underground place where the water is cold. And then you take this cold water and you pump it through the uh, reservoir of the hot steam. And by doing so, you create some water, some colder water. And then you take this cold water and you reuse it back into your steam generating system. And then also, once you have this cold water, you can go through here, it becomes hotter, and it goes through here. And sometimes, you can recapture it, it can go back into the water side. Or sometimes, because it's too hot, it just becomes steam, and it exits through the cooling opening in the top. And that's where you see all the steam coming out. Those are the steam from the coolant. And that's how the system works. And some safety measures that the system uses So first of all, you can see that all of there's a bunch of these pipes that are all separated. So we have one pipe here system, one system of pipes here, and one system of pipes here. And you can notice that I drew a box around, the place with the reservoir and the pipes for the reservoir. And the reason I did that is because in real life we have a very secure. Sorry, sorry. I thought I had statistics on this, but I didn't. So we have a very secure container, right? And this container contains the, you know, radioactive materials, and it contains that. And so the reason we have this huge container that's very protective and very secure is because, if you can imagine, if this fails, if one of the pipes fails, so this pipe fails here, then what's going to happen is it's going to build up. This chain reaction is going to continue, continue, continue. It's going to be really hot. It'll melt, nuclear meltdown, and it's going to, the radioactive material is going to leave this reservoir. And when it leaves, it's going to go into this container. And that is, by having this container, it's your last kind of barrier to the outside world. And so this container kind of prevents the material, the radioactive material, from exiting. And that's the reason why we have so many pipes, because if this pipe fails, then the material is still stuck in this container. And so if this pipe fails, then, it's stuck in that container. And I think that's basically it to nuclear reactors. Oh yeah, one more thing. Also, inside the reservoir, nuclear reservoir, you have this material called heavy water, and this is D2O, and it acts as a moderator. It's called a moderator. And basically, what it does is it makes the chain reaction a little slower because it's a little harder to go to heavy water versus regular water, and so it slows down the chain reaction of the fission by just being there. And yeah, that's how nuclear reactors work. Really, they're quite similar to how other conventional thermal power plants work because they just require heat and they create steam that turns a turbine. But I think that they're really interesting, and yeah, thank you guys all for watching, and I'll see you guys all tomorrow.